Hello, um, my name is Nick Lavery. I'm the coordinator of EGA324, and this is probably the first place you should be looking at, and it kind of forms a quick plan of study and overview. There's obviously more in the online e-lectures and everything, but I just wanted to make clear this module is made up of two parts: the laboratory experiments, the physical experiments, and the computational modelling. Now, through the term, you will be looking at these experiments, and they'll involve subsonic wind tunnels, the use of universal testing machines, but you'll also be learning how to develop models in ANSYS, and we'll do this in 3 stages throughout the entire term. There'll be a beginner, an intermediate, and an advanced phase of ANSYS. We will be aiming to achieve 3 main learning objectives. One is we will get you to the point where you'll be able to write an advanced technical report of the experiment. Then the second learning objective is obviously the engineering practice itself. We learn about the experimental techniques and underlying writing a test program, experimental test programming, and the use of suitable measuring equipment. Then the final part, learning objective, is to get a greater understanding of computational validation, and this will be done through the use of ANSYS. There will be 3 main assignments on this module. C1 in February, which is worth 20% of the entire module, which is 10 credits. C2, which will be worth 30%, and that is due in March. And C3, which will be then due at the end of the module in May. There will be a series of online tests prior to each experiment. All students undertake this pass-fail quiz based upon watching an online video of the experiment. This is primarily to get a good understanding of the health and safety, but also to get a good idea of the experiment before you have to do it, so you can plan your experiment on the day. There will be online pass-fail tests on ANSYS based upon the tutorials undertaken throughout the week. So on this page you should be able to see below the overall schedule. You will see that most of the experiments go through 2-week blocks. The first 2-week block, weeks 1 and 2, will be the aerofoil experiment, which all groups will undertake. If you want to see where you can find your groups, have a look below. There's an Excel file. You've been randomly allocated to one of 32 groups. The second 2-week block is the boundary layer experiment. The third 2-week block is the stress concentration experiment. And then the fourth experiment is the bolted joint, which is broken up this time by the Easter recess, through which there will be no more experiments. Also in the schedule that you can see below on this page, you'll see the ANSYS training and how it will phase you through from beginner through to advanced stages. The final assignment is due after Easter, and you'll have a 2-week period to undertake a computational model and validation of one of the experiments of your choice. So these will probably be one of the aerofoil boundary layer or the stress concentration experiment, and you will write that up on the final week of term, which is when the last assignment is due. Okay, so I hope that you enjoy this course, and I look forward to meeting you all at the overview lecture, which will be at the beginning of term. All the best.